The final section of trigonometry that we look at is the application of trigonometry. And that's basically where we look at real life situations and we start to see triangles, and it helps us to work out certain lengths, heights, and angles. Okay, and in order to do that, we just need to make sure that we've got a solid foundation. So remember, SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And then remember that there are also the reciprocals. So in other words, if we swap these around and we have instead hypotenuse over opposite, then we are dealing with cosec of the angle. If we have hypotenuse over adjacent, then we are dealing with sec of the angle. And if we have adjacent over opposite, then we are dealing with cot of the angle. And these can be expressed as 1 over their reciprocal there. So the reciprocal of cos can be written either as sec or as 1 over cos. And the reciprocal of tan can be written as either cot or 1 over tan. Okay, and these are actually a lot easier because they all appear on our calculator. So this is my preference here, but all of them are true. It just involves remembering how to calculate when it comes to those real life situations. The other foundation that needs to be in place before we tackle our real life applications is just the ability to, once we've set up our equation, to actually solve it. So remember, we looked at two things. We said either we're missing a side and we are given an angle, and then that's straightforward. So you just pick up your calculator and you type in there sine 60, and it gives you an answer there of root 3 over 2, which we can then just put into decimal notation, so 0.87 units. Okay, then we get the second case where the angle is missing. So we've been given a value here. Half is equal to sine of angle something, and we need to calculate. And that's when we're going to use the arc sine option on our calculator. So we can say angle P is equal to arc sine of 0.5. And so to do that on the calculator, we need to push that shift button. So shift sine 0.5, and that gives us an answer there of 30 degrees. Okay, in this section, units are very important. So remember, if you're working out a side, have a look. Is it in meters, centimeters, etc.? If not, you can just say units. And then if you're working out an angle, we measure angles in degrees. Okay, and then to set up these equations, we just need to remember this little rhyme: the side I want over the side I have, or the unknown side over the known side, and then that is either equal to sine or cos or tan, the trig ratio. That's what that means. Let's make a note of that: sine or cos or tan of the specific angle that they give us. Okay, and if you've got all those foundations in place, then we can dive into the real life examples. So this is the kind of situation that you can expect to see. You can have a person standing over here, and they could be looking up, let's say, at this eagle flying in the sky, or they could be looking down here at this little rodent, and we can be asked to work out certain things, like how much higher is the eagle than this little rodent, or something like that. Okay, but in order to translate their questions into trigonometry, it's very important for us to have a good grasp of these two words. So we get angles of elevation and angles of depression. Okay, so elevation makes us think upwards, and depression makes us think downwards. And if you can remember that, you're going to be okay. So if we consider this person standing here and their little scenario of looking at these two animals, we can see that he would need to look up to see the bird. So that's probably going to be something to do with elevation. And then he would need to look down to see the rat down there. So that's going to be something to do with an angle of depression. But we need to actually figure out where these angles fit in. And that is where this horizontal line is absolutely essential. Okay, so we always need to remember that the angle of elevation and the angle of depression is linked to a line that is parallel to the horizon. Okay, so that's a flat line there. In other words, if we were to look at the ground that this person and this rat were standing on, then the line would be parallel to that. Okay, and so now we can add in and we can say, actually, angle of elevation fits in over there between this horizontal plane and the line that looks up. So that's an angle of elevation. So if I say to you, this person is looking at the bird in the sky at an angle of 20 degrees, then you would know there's an angle of elevation there that is 20 degrees. And then in a similar fashion, the angle of depression is again then from the horizontal down to the line that is looking towards the item on the ground. Okay, so we've got angles of elevation, angles of depression, and it's very important that we know that if they are written in a description and not drawn in a sketch, we need to know where to draw them. So let's start here and look at a very simple example of this. And you'll see that although it seems like something that's going to be very scary, it's actually very straightforward trigonometry that we get to use here. So Sam is sitting on a beach 4.5 meters away from the tree. He wonders how tall the tree is. Calculate the height of the tree if the angle of elevation from where Sam is sitting is 38 degrees. Okay, now we've been given a sketch here. If we were not given a sketch, my first advice to you would be draw a little rough sketch. Okay, now these sketches don't have to be exactly accurate. You can see here the palm tree is at a slight angle, but at the end of the day we could still measure to the top if we use the information that they've given us. So the key here is not to overthink. We just need to get triangles in place because we know trigonometry works best with triangles. Okay, so now we can put our details together. We know that Sam is sitting on the beach and he's 4.5 meters away from the base of this tree here, and we want to know how tall is this tree. So let's call that T for tree. And then in the background there you can see we do have a triangle that has been drawn for us. Okay, and in that triangle, very importantly, is the angle of elevation. So what we need to do is we need to check, is there a horizontal plane and a line going up? Because that means we have the angle of elevation there between those two. And that is the case. Okay, and often they do draw it for us. So don't panic too much. But if they haven't drawn it for us, we then need to know where to fill it in. Okay, so now we can use our trigonometry that we know, which is to say I want the unknown side over the known side, and I want to make it equal to trig of an angle. Okay, so let's see. The unknown side is the height of this tree. So let's call that h, because that's what Sam is wondering about. Over the known side there is 4.5 meters. Okay, and then it needs to be either sine or cos or tan of the 38 degrees that we've been given. Now let's go to our triangle and let's figure out, if we are working with 38 degrees, where is the hypotenuse? Well, the hypotenuse is always across from the 90 degree, so we're going to pop that in there. Where is the adjacent? The adjacent is always next to the angle we're working with. And where is the opposite? Opposite is always the one across. Okay, so not to be confused, I'm actually going to change this and call this capital H that's missing, just so that I don't confuse myself with too many H's. Okay, so now what I like to do is just allocate and say, okay, the side I want is the opposite over the side I have is the adjacent, and then I go to SOHCAHTOA, or however you remember sine, cos, and tan, and that helps me to see that opposite over adjacent is equal to tan. So this is equal to the tan of 38 degrees. Okay, now to calculate that, I can simply multiply this side by 4,5 because that'll cancel. And what I do to the one side, I do to the other side. So then we end up with the fact that h is equal to 4,5 tan 38. And that, we are given the angle, so that means we don't have to shift anything. We can just type it straight into the calculator. And there we get an answer of 3,52 meters. Okay, so I went here and I said, what was the measurement given in? That's what my answer will be in. So that's a real life application of our foundational trigonometry. Let's look at one more really cool example. We've got a red building 200 meters away from the base of a clock tower. We need to calculate the height of the tower if the angle of elevation from the top of the building, there, point A, to the top of the tower, point T, is 34 degrees. So they're telling us here we need to put in an angle of elevation. Okay, so the first thing I do is I check, is there a horizontal line? Because if there isn't, I need to draw one in. Okay, but they've given us one, which really does help me, because then I can just say, okay, well, the angle of elevation there is 34 degrees, and I can pop that straight in. Okay, the angle of depression, let's have a look at that now, from the top of the building to the base of the tower, so there's the top of the building, to the base of the tower, point C, is 62 degrees. Now be careful. We're tempted, possibly, to write it in here, but remember, angles of elevation and depression, they always come from a horizontal line. So that's 62 degrees actually needs to fit in there. Be very careful of that one. Okay, what they've asked us is to calculate the height of this building here, this tower, okay, and we are going to need to do it step by step because we need a bit of information. What I can see here, thanks to the little dotted lines, is that this line here is also going to be a 200-meter line because this is all perpendicular. So that's one good thing, is that I've got some information up here, but there's no nice 90-degree triangle that links here perfectly to this clock tower. And so that's not a problem. It just means that I am going to need to work towards breaking this up. And so what I propose, we've done triangles in sections before. What I propose is that we deal with a top yellow triangle and then possibly a bottom blue triangle here, and then we see if we add those two heights together, that will give us the overall tower height. Okay, so let's have a look if we can do that, knowing that that length there is also going to be 200 meters. Okay, what we can do now is then calculate in terms of each of them. So I'm going to put an opposite, adjacent, and a hypotenuse here with regards to that 62-degree angle. Okay, hypotenuse is there, opposite is there, adjacent is here. Okay, so side I want is opposite. Let's call this now, I'm going to call it tower 1 and tower 2, the side lengths there. So I'm going to say T1 that I'm looking for over the 200 meters is equal to something, sine, cos, or tan, of 62 degrees. That's going to be my first calculation. And then I'm going to have to work out what exactly I'm dealing with. So T1 is O, over the 200 is adjacent, and that means we've got tan once again. So tan of 62 degrees. So T1 is equal to 200 tan of 62 degrees. And let's calculate that on our calculator. So 200 times by tan of 62. That gives us an answer of 376,145,2931. Okay, I'm keeping all the decimal places because this is not the answer to the question. So in maths, we never round off until the final step. We need to keep all of those decimals so that when we finally get the overall height of the tower, we round off. Okay, next up we move to the yellow triangle. So let's get our opposite, adjacent, and hypotenuse in place there. Opposite, hypotenuse, adjacent again. Okay, we this time want to have T2 over that 200. So let's have a look at that. T2 is opposite over adjacent. Oh, it's tan again. So is equal to tan of 34 degrees. And then we multiply that 200 across. So T2 is equal to 200 tan of 34 degrees. Let's see what that's going to equal. 200 tan 34 gives us an answer. Remember all your decimal places. 134,9017034. And then the total height of the tower we can now add. So it's T1 plus T2, which is equal to 511,01 meters. So there we have it. We can work out, using our knowledge of angles of elevation and depression, we can work out loads of very practical things in the real world.